Hey everyone, welcome to today's Explainer. I am absolutely thrilled to get into this one with you because honestly, we're looking at something that fundamentally shifts how we interact with technology. We're tracking the dramatic evolution of AI memory. We're talking about the journey from an AI experiencing complete exhausting amnesia to the dawn of true, persistent machine intelligence. So get ready, because the architecture we're unpacking today, it completely redefines what it means to actually have a digital assistant.
I want you to just imagine something for a second. What if your absolute smartest assistant, the one who can process complex data in a matter of seconds, what if they just simply forgot everything, every single morning? Think about that visceral, exhausting reality for a minute. Every Tuesday morning, millions of professionals log into their AI tools and experience what honestly feels like an unspoken betrayal. You're typing out the exact same corrections, you're fixing the exact same formatting errors over and over. And that's because, until recently, AI essentially had the functional lifespan of a mayfly. It woke up brand new, completely empty-headed, and entirely amnesiac every single time you hit new chat.
Okay, let's dive right into this. The daily amnesia loop, or the summer intern problem.
To really understand the cure, we've got to look closely at the disease of that old world AI architecture. You know the one, where your context limit is just constantly maxing out. We've got this old paradigm of treating your AI like a temporary summer intern. You spend hours training them, getting them totally up to speed on your project, and then poof, their session ends, their memory wipes, and the very next day you are starting from absolute zero. It is incredibly frustrating. But there was a massive architectural shift on June 18th, 2026. This was the launch of Perplexity's Brain. And this new architecture, it completely stops treating the AI like a stateless summer intern and starts treating it like a tenured analyst with a persistent performance logging memory. Moving on to the glowing context graph and looking beyond static preferences. So how exactly does it achieve this? Well, this isn't your traditional old-school personalized memory. Old-world memory was essentially just a static text file of your preferences. You know, stuff like, John likes short emails or use a friendly tone. The context graph doesn't care about your vibe. It is a dynamic, living, glowing 3D web of interconnected knowledge. It acts as a traceable performance log documenting exactly what the agent actually did. Every single action, every tool call, every user correction, it's all mapped out and remembered. And this brilliantly illustrates the concept in action. We can see a path where the AI attempted a search query, hit a dead end, actually learned from that failure, and then autonomously executed a successful model switch to Claude Opus 4.6 just to get the job done. By noting those dead ends and model switches, the graph is literally building an autonomous LLM wiki directly into your local sandbox. It remembers not just the final answer, but the entire journey it took to actually find it. Let's explore the AI's crucial sleep cycle using a biological metaphor. So you might be wondering, when does all this memory building actually happen? To really grasp this technological leap, we need to map it onto human biology. Just like you and I need sleep to consolidate our memories, the Perplexity Brain does something remarkably similar. Step 1. It enters a hyper-accelerated dream state, where it completely disconnects from active user prompting. Step 2. It prunes its pathways, intentionally discarding all the useless data and failed queries from the day. And Step 3. It synthesizes. It strengthens the successful connections and updates that LLM wiki. It is literally processing the entire day's work overnight. But here's the wild part. It's not just dreaming in isolation. While you're physically asleep, the AI is actively working. It's running incremental updates. It actively connects to live enterprise data warehouses like Snowflake and integrates directly with Databricks. It takes all of that raw enterprise data and synthesizes it with your daily interactions to map your exact intent. It is quite literally doing its homework while you rest. No way, right? Bringing us to the autonomous living wiki, your self-updating project context. By morning, that graph has morphed into a highly structured, auto-written wiki. You wake up to an entry for Victor's research style, another for trusted sources, and a highly distinct log of dead ends to avoid. And get this, it even documents complex workflows, like how we evaluate African remittance corridors. You didn't write a single word of that. The agent wrote that entire complex workflow documentation itself, based entirely on its observations of your past sessions. It's truly a living organ of project context. So the crucial point is summarized perfectly by the phrase, every run starts with full project context. Because this vast auto-generated wiki is silently reloaded into the system before you even type your very first prompt of the day. The AI wakes up with a massive, unfair competitive head start over any general-purpose model on Earth. It already knows the goal, the context, and the pitfalls before you even ask.
All right, let's quantify this AI intelligence and look at the bottom line.
Now, a biological metaphor is great for understanding the mechanics, but let's be real, we need to look at the cold, hard reality of the business impact. Now, what's really interesting about these numbers is the sheer scale of the quantified upgrades. We are seeing a massive 25% boost in answer correctness on repeated tasks. And right alongside that, a 16% increase in pure recall capacity. Because the AI isn't starting from scratch, because it actually has that tenured analyst memory. Its accuracy and its ability to pull relevant historical data just absolutely skyrocket. And then there's this number, negative 13%. Honestly, this is perhaps the most impressive metric of the whole bunch. Despite being infinitely smarter and way more context-aware, there is a dramatic 13% reduction in computational token cost. By pruning those dead ends during its sleep cycle and only loading the synthesized successful pathways, the AI becomes incredibly efficient. It doesn't waste precious computing power barking up the wrong tree.
Let's move to our final point and see how this builds a totally new challenge. Beware the recency trap, or the invisible prison.
Because any system this powerful, it comes with a completely new set of risks. So I want to leave you with this final, somewhat ominous question. What happens when your assistant falls in love with the last thing you said? We've built an incredible, highly sensitive memory architecture that learns from your every single move. But if it learns a mistake, or if your project context shifts suddenly, the AI might fiercely cling to an outdated paradigm. This is exactly what engineers are now calling the context trap. Think about it. When your AI is no longer a blank slate, how do you change its mind? It's a fascinating dilemma, and it's exactly what we'll be exploring next time. Thank you so much for joining me for this explainer, and remember, keep questioning the systems you built.